7, 8. Number 8 is viscosity. Look at viscosity. Definition: viscosity is the opposition to the flow of fluid particles in motion. Viscosity is the opposition to the flow of fluid particles in motion. Full stop. It is also the internal friction, viscosity. It is also the internal friction, viscosity. It is also the internal friction that occurs between the internal friction that occurs between the layers of a fluid in motion. That occurs between the layers of a fluid in motion. Full stop. So here's what we know. For solids, we said when two solid bodies rub against each other, heat is generated. The heat comes from the frictional force between the two bodies. Now what about liquids? What about liquids? Because if liquids are flowing, of course, particles of the liquids are rubbing against each other. So does friction occur in liquid? Yes. The friction in liquid is called what there? Viscosity. This explains why palm oil gets thick after being used. Get a freshly made palm oil, right? Use it for cooking. It flows very fast. Keep it for some weeks. Try to use it. Turn it upside down. It comes up what there? Sluggishly. What has happened? When you kept that palm oil there, viscous force has developed within the palm oil. So it becomes sluggish. Why is it sluggish? Because there's a frictional force between the layers of the palm oil that is trying to retard its motion, and hence it comes up what there? Sluggishly. If you want to make it come out very fast, what do you do now? Keep it close to fire. Becomes faster. When you keep it close to fire, what's the concept there? Concept there is that by keeping that oil close to fire there, you have broken the viscous force. It starts flowing up faster. That's it. Very important law here. Next up is Newton's law of viscosity. Newton's law of viscosity. Newton's law of viscosity states that the shear stress on a crude element layer, the shear stress on a crude C-R-U-D-E, crude element layer is directly proportional on a crude element layer is directly proportional to the rate of shear deformation. Newton's law of viscosity states that the shear stress on a crude element layer is directly proportional to the rate of shear deformation, or in bracket shear strain, whichever way. It's called a shear deformation, it's called a shear strain, also called velocity gradient. Very important. Very important. Also called velocity gradient. I think that's like Leo's favorite. We call it a velocity gradient. Right. The shear stress on a crude element layer is directly proportional to rate of shear deformation or shear strain or velocity gradient. Mathematically, we are saying this. Look at this. Of course, your idea of Mohr circle last semester, shear stress was what there? Tau, abi? Yes. Yeah. So the same thing here. We've seen that tau, shear stress, is directly proportional to what there? Velocity gradient. Can you guess the I won't say ballistic gradient, what will it be? Huh? UDX. Yes, actually du over dy. Right. It's called velocity gradient. I think I said when something is a gradient, it means it's what there? Changing with respect to another parameter which is not what there? Time. I said so. So you have velocity changing with respect to height. Why there is a vertical distance, that's the height. So it becomes a gradient. And that's it. Next up, get unit. Get unit, please. This one is a stress. Stress is force over area. That becomes what there? Newton per meter square. For this man, what's the unit for this one here? So this is du over dy. Du over dy. This is u, that's velocity in meters per second, all over. This is distance in meters. So my unit becomes meters over second divided by meters. So meter per second all over meters. From here, it gives you meters per second. Change here to times and invert this one, becomes 1 over meter. This cancels this. So I'm having equal to 1 times 1 is 1 all over s. The SI unit for ballistic gradient is what there? Per second. Please. This man is measured in per second. In per second, please take this back seriously. SI unit is per second. You go and give you this in per hour. Let's convert to per second. Alright. Let's break this down. Let's break this down, please. We said from Newton's law of viscosity that tau is directly proportional to du over dy. Normal mathematics, if I have a proportionality sign here, we said take it off and put what there? A constant. In this case, I'll have that tau is equal to my constant here is this. It's called mu. I'm having du over dy. So tau is equal to mu du dy. Tau is equal to mu du dy. It's mu, not mu. Not mu, it's mu. It's spelled mu. Pronounced mu. Mu. Now you talk that one. I'll go and check it though. Where's the E from or the I from? No, it's mu. I told you. I think I was going to do that. Is actually what? It's your record. Yes. I was going to actually told you mu, but it's not actually mu. It's actually mu. Actually, it's mu. The stop. For the stop for Greek is for English is mn. For Greek is munu. Right, so you have mu and then nu. Check it out, it's mu and nu. And funny enough, these two actually represent your viscosity. There are two types of viscosity. This one is for dynamic, this one is for kinematic. Look at them briefly. So there's m and n, mu, nu. Alright, so you have this place. Where this is the constant of proportionality known as dynamic viscosity. This dynamic viscosity. Oh, get me units here. What's the unit here? Right. This man, look at it. This man here becomes, look at this. Play with this. I'll have to divide this man here by du over dy such that these two cancel out. That means mu is equal to this one here, tau, all over du over dy. Now ignore parameters, play with units. We said tau here is Newton per meter force over area, Newton per meter squared, that's for this one here, divided by tau. Tau we said is per second, so divided by 1 all over second. This will now be equal to having Newton per meter squared change here to times, obviously inverts, so I have this. So hence, the SI becomes Newton times S, Newton seconds all over meter square times what? Meter square. That becomes Newton seconds per meter square. So we have this. That's the SI unit for dynamic viscosity. Newton seconds per meter square. Have this. Alright. Types of viscosity. Types of viscosity. There are two types. Of viscosity. There are two types of viscosities. You have dynamic viscosity, you have kinematic viscosity. Number one, please. Dynamic viscosity. Dynamic viscosity, please. We said it is the ratio of shear stress to velocity gradient. Of shear stress to velocity gradient. It is abbreviated by the Greek symbol, this one here. So that's mu. Right here, that's mu. Oh, we said mu is equal to tau all over du dy. We have this, and we got this one here as Newton seconds per meter square as your SI unit. Don't forget this one. I've already done it already. So yeah, first one there is dynamic viscosity, Newton seconds per meter square. And this, don't forget, this one here is force over area. Don't worry, take pictures. Don't worry. Take that, please. Dynamic viscosity can also be measured in points. Points on what? Dynamic viscosity can also be measured in points. You have this. That's this. So here's the relationship in points, where 1 Newton second per meter square is equal to 10 pounds. So that's the relationship, please. 1 Newton seconds per meter square is equal to 10 pounds. Have this. Have this. So if you want, you can add this as a note. Note, to convert from Newton seconds per meter square to points, multiply by 10. To convert from points to Newton seconds per meter square, divide by 10. Very important, please. To convert from Newton seconds per meter square to points, multiply by 10. To convert from points to Newton seconds per meter square, divide by 10. Alright, kinematic viscosity. It is the ratio of dynamic viscosity to mass density. It is the ratio of dynamic viscosity to mass density. Mass density. It is represented by the Greek symbol. This is called nu. So mu for dynamic, nu for kinematic. Mathematically, we have that nu is equal to, we said, dynamic viscosity, that's mu all over mass density. Case of down B, get out the SI unit. This man here, we said, is in Newton seconds per meter squared. This one here, mass density, mass over volume, mass in kilogram all over volume in meter cube. So what then is your SI unit? Here's how to go about this, please. This should now be Newton seconds per meter squared. This divided by kilogram per meter cube. Obvious to solve this one here, change here to times and then invert them. This man comes to numerator, it becomes meter cube, goes down, it becomes kilogram. So what happens is this? This here 1, this here meter, of course 2, 3. I'm having this one here. So this is now equal to, if I multiply this, it gives you Newton seconds meter all over kilogram. This one here is not in its basic state. We can still break this down. Why? Newton is force, and force, as we know, is equal to mass times gravity. That means in a Newton or a force, there is mass, there is kilogram. So you can get kilogram from Newton. So bring this one down again. So we are saying that 1 Newton force is equal to mass, that's kilogram, times gravity, that's acceleration due to gravity. Acceleration is meters per second squared. So it means that 1 Newton is equal to 1 kilogram meter per second squared. 1 Newton is 1 kilogram mass meter per second squared acceleration. Bring this man under here. I will have this to be Newton is kilogram meters per second squared. That's your Newton times second times meter all over kilogram. So times seconds times meter all over kilogram. Play with this. This can cancel this. It's up. Meters times meters is equal to meter squared. Meter squared. These two multiply, I have x. We said add the power. Minus 2 plus 1 minus 1. Hence, the SI unit of kinematic viscosity is meter squared per second. Please, take me please. Meter squared per second. Let me write it here. Meter squared per second. When we start the main, this one is just introduction to fluid. When we start the main fluid, we'll see why you need all these things. If you're here, kinematic viscosity is also measured in Stokes. Kinematic viscosity is also measured in Stokes. S-T-O-K-E-S. In Stokes. So here's a relationship. 1 meter squared per second is equal to 10 to the power 4 Stokes. 1 meter squared per second is equal to 10 to the power 4 Stokes. For quarts, it's just 10. For Stokes, it's 10 to the power 4. Please note it. Okay, so we have this. To convert from meter squared per second to Stokes, multiply by 10 to the power 4. To convert from Stokes to meter squared per second, divide by 10 to the power 4. Very important. To convert from meter squared per second to Stokes, multiply by 10 to the power 4. To convert from Stokes to meter squared per second, divide by 10 to the power 4. Alright.